Evaluate the algebraic expression a squared over b squared plus b squared over a squared, where a, b are greater than 0, satisfying 1 over a plus 1 over b equals root 17 over root ab. By finding a common denominator of the two terms on the left-hand side of the equation, we can now write b plus a over ab equals root 17 over root ab. Now square both sides of the equation. By expanding both sides of the equation, we can now write a squared plus 2ab plus b squared over a squared b squared equals 17 over ab. By rearranging the equation, we can now write a squared plus 2ab plus b squared equals 17ab. By simplifying and rearranging the equation, we can now write a squared minus 15ba plus b squared equals 0. To evaluate a squared over b squared plus b squared over a squared, one approach is to solve equation 1 by writing a in terms of b, then substitute a in the algebraic expression. However, this might be computationally intensive. We have now simplified the given equation. Now we'll simplify the given algebraic expression. So we can now write a squared over b squared plus b squared over a squared equals a to the power of 4 plus b to the power of 4 over a squared b squared, which can be written as a squared plus b squared all squared minus 2a squared b squared over a squared b squared, which can be written as a squared plus b squared over ab all squared minus 2. From equation 1, a squared plus b squared equals 15ab, so a squared plus b squared over ab equals 15. So we can now write 15 squared minus 2, which is equal to 225 minus 2, which is 223. Thank you for watching. Hope you found this video helpful. Please subscribe to this YouTube channel for notification of new videos. See you next time.